So in this lesson, you're going to learn how to write formulas from a name for a very specific type of compound known as a ternary ionic compound. A ternary ionic compound. Ternary just means that there's at least 3 elements in the compound. And what that really means is that there will be a polyatomic ion in the compound. So we're going to start with some examples, and then we'll write down a list of how-to steps. So our first example that we're going to look at is a compound known as calcium sulfate. And so what we need to do in order to write the chemical formula from this name is we have to recognize that the name, the 2 parts of the name, is going to give you information about the 2 ions that you'll need. So the first thing we're going to do is we're going to start by looking up the charge of a calcium ion, because that's the first part of the name. So calcium is a +2 charge. So we write that symbol, Ca +2. And as for the sulfate, we are going to need to go to reference table E, and we're going to look up and find sulfate. So sulfate is listed here. Sorry, it's got some marks on it. Sulfate is listed here as SO4 with a -2 charge. So that's sulfate. Be careful that you're not looking at sulfite. Sulfate is SO4 -2. So now we're just going to write this formula the same way that we did with the binary compounds. Remember, the goal is to make the compound neutral. And since we have a +2 and a -2, we just need one of each. So what we do is those charges disappear, and we just need to indicate one of each. We put the cation sitting right next to the anion, just like that. And this is indicated as one of these and one of these SO4. So this is the formula for calcium sulfate. Our second example is copper 2 nitrate. Okay. And so what we're going to do is we're going to go to a periodic table. And on this periodic table, we're going to look up the charge of copper 2. And actually, we don't really need to do that because copper can either be a +1 or a +2. But when they give us a Roman numeral, that's telling us what the charge is. So we just need to write down that the symbol for copper is Cu, and the charge is going to be a +2. That's the Roman numeral. It's like a shortcut to knowing what the charge is. But then we're going to look at our nitrate. We're going to find nitrate on our reference table E. So nitrate is NO3 with a -1 charge. So I'm going to put that NO3 in parentheses and put a -1 charge next to it. And at this point, we do not have equal and opposite charges. So this is where we're going to use the drop and swap, right? Where we take the charge here, and that becomes the subscript down here. The charge here becomes the subscript down here. And of course, this one subscript is understood, so we're just going to drop it. And then this NO3, we need 2 of them. This 2 out here tells us that we need 2 of these NO3s. So we need to keep this NO3 in parentheses and put that subscript of 2 outside of the parentheses. That's telling you that you need 2 total of these NO3 groups to match up with the 1 copper ion. Another example is calcium permanganate. And we already saw from the previous problem up above that calcium is a Ca +2. Now permanganate, you may not have seen this one before, but permanganate is listed here. So its formula is MnO4 with a -1 charge. So MnO4, I'm going to put that in parentheses and put the -1 charge outside of it. So again with the crisscrossing, so calcium is going to have a subscript of 1, and I'm not going to write it. And then right next to it, I'm going to write MnO4. But this 2 now becomes our subscript. We have to keep those parentheses because we need 2 of the whole MnO4 group to match up. So that's our formula for calcium permanganate. One more example here. We've got lead, Roman numeral 4, sulfite. So the symbol for lead is Pb, The charge is a +4. That's the Roman numeral 4 telling us it's a +4. From reference table E, we see that sulfite is SO3 with a -2. So SO3 with a -2. Now when we crisscross, we're going to get Pb2, SO3 in parentheses 4. But this is a situation where you're going to have to notice that 2 to 4, that ratio of 2 to 4 can be simplified. So this becomes Pb SO3 in parentheses 2. All right, so now let's go ahead and write up a how-to set of notes for how to kind of to capture the process in words so that you can come back to this and understand how you got those formulas. So if you were being asked to write a formula from a name, the first thing that you need to do, or that you need is to do these, is you have to be given a name of a compound. So in this case, we'll give you a set of instructions here, and we'll run through another example over here so you can see how this process works. So we're going to use as this example nickel 2 phosphate. Nickel 2 phosphate. Okay, what you're going to need here is you're going to need to use a periodic table. A periodic table and reference table E. To write down your ions. Because remember, the name has two parts to it. There's a cation and there's an anion. And now we just have to write down their symbols right here. So this is going to be Ni plus 2, because nickel is the symbol Ni. The Roman numeral 2 is telling us it's a plus 2. Phosphate from reference table E, phosphate is right here. So it's PO4 with a -3 charge. PO4 with a -3. Okay. So the second step, from the name, we're just writing out the formulas right there. The third thing to do is the drop and swap. And that sounds really simple, but there's a couple things you have to remember as you're doing this. Okay. First of all, you lose the positive and the negative signs. When you are writing subscripts, they are never positive, they are never negative. They're always just the number, because it's a count. When you write them as subscripts, they're counting how many. When you write these numbers as superscripts, it's a charge, so you have to put a plus or a negative sign in front of it. So when you drop, you lose the positive and negative signs. Another thing you have to remember is to simplify, if necessary. Another thing to remember is don't ever change the subscripts in a polyatomic ion. So in other words, if you see a subscript and it's part of one of these polyatomic ions, like for example this 4 or this 2 or this 3, those numbers are kind of sacred. You don't touch them. They are part of the polyatomic ion, and they are not ever going to be, you're never going to change them. One other thing to remember is that you lose the parentheses if, whoop, that's a strange looking if. Lose the parentheses if you only need one of the polyatomic ion. Which means keep the parentheses if you need more than one of the polyatomic ions. Whew, that's a lot to remember. For drop and swap, that sounds so simple, but these are all the things you have to keep in mind as you are dropping and swapping. So let's see how that works for this example. I'm going to rewrite my ions down here so it's more associated with this set of instructions. So we had Ni plus 2, and we had PO4 minus 3. So we're going to take that 2 and put it down there, and we're going to take this 3 and put it down here. So let's clean that up. We have Ni subscript 3. And then right next to it, you're going to put the PO4. We have to keep the parentheses because we needed more than one of them. So we're going to keep the parentheses around the PO4 and put a subscript outside. So there you go. There's your set of instructions on how to write chemical formulas from names for ternary ionic compounds. These are compounds containing polyatomic ions. All right, we'll see you back in the classroom.